Okay, please work, please work, please work. Excellent connection, nice. Okay, I think it works now. That's really nice. Now I just need to find out how to copy this link over. Does that work? No, that's just, okay. I haven't streamed for a long time, so I'm sorry for the possible scuffiness of the first few minutes of the stream, but it's okay. Okay, let's try. Unless, no, I don't care about that. No, 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 no. Let's go to another, let's go right here, another tab, and then go here. I know you guys don't see what I'm doing right now, but that's because I am not on what I'm supposed to be on. Okay, right here's the stream, so I'm just gonna look at my own stream. What I'm supposed to be on. Okay, that might repeat. Oh no. Right here. Oh, it actually says it on my Discord. I didn't even have to do that. Anyways, today we will be doing the AMC challenge. Now, you guys don't know what the AMC challenge is. The AMC challenge is the American Mathematics Competition Challenge, and American Mathematics Competition is the first competition that is required for you to take in order for you to progress up in the competition ladder. There's a bunch of competitions that you have to do to get into the International Math Olympiad for the American USA team, and the AMC is the first one of them. And today we're gonna have a forfeit, or a challenge, basically, or punishment, right? A forfeit's a punishment. So if I can't do something, I will have to be punished for it. And in this case, I have 25 questions. I have to answer them in 75 minutes. And 96 is the score to beat. So 96 is the score that will get me to the next competition, which is the AMI in this case. So that 96 is the score to beat. If I can beat 96, then I don't have to do the punishment. If I can't beat 96, then I will have to do the punishment. And I don't know what punishment I should do. So if you guys please can suggest punishments for me to do, then please do so. If you guys don't want to, if you guys just want to watch me, then I'll probably just think up of a punishment myself. It will be recorded, and then I will post it onto my main channel. Actually, no, I'll post it on this channel. Just for the fun of it. But anyways, we'll wait for a little bit more, maybe 2-3 more minutes. I don't think anyone's watching right now. There's 0 viewers, which is sad. But anyways, so 25, we need a 75-minute timer, that is. And I think you guys will be able to hear the audio from the computer, like beep, 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 sort of stuff. You guys will be able to hear that audio from the computer once the timer ends. And in fact, I should probably also add an extra, let's see if I can do it during the stream. So window capture, okay, I don't want that though, because that will be doxing myself. I don't want to do that. So there you go. And then I probably should have prepared for this. Right there's the time. right? And let me see if I start this and then I do the work. Will it still run? Yeah, I think it'll still run. Nice. Okay, that's a very, very good thing to know. So yeah, we'll start the timer. We'll wait a little bit for people to start trickling in. We will start the AMC at 12 p.m. Or no, not 12 p.m. I mean 11 p.m. Or 11 a.m. 11 a.m. Not 11 p.m. So yes. Let's wait for people to trickle in. Meanwhile, I will explain to you the rules of the MC. The rules is you are not allowed to use a calculator. So if you use any calculator, you are done. You can't use a calculator. For the geometry questions, you are allowed to use a compass and a straight edge. And I have a straight edge. Or you can also use a ruler, in fact. However, the objects are not to scale. So if you use a ruler and you think that the proportion is like that, but it actually isn't, then, well, you're out of luck because the proportions are not to scale. So it's probably best to use a straight edge and a compass and construct your shapes rather than use a ruler and try to pinpoint how many centimeters it is exactly or whatever. Plus, it's going to be digital anyway, so it's not like it matters. It's not like it matters. And also, in this competition, usually it's taken on paper. But I'm just doing it on digital because that's how I can live stream easier. I don't want to use a digital, I don't want to use like a camera and face it down. That's kind of dumb. That's really hard to also set up because I don't have a camera other than my phone camera. So it'll probably just be filming my head while I'm trying to do it. It'll be something like me putting my phone on the place where I would normally have a face cam, and then that would just be a mess. So I don't want to do that either. So I'm just gonna have to use a ruler, a pencil, paper, and obviously the Active Inspire board that I have. I don't know. I don't think you're allowed a protractor, but you're definitely not allowed a calculator. Yeah, all of these problems can be done without using a calculator, so that's why they don't like it when you use a calculator. That's why they don't want you to use a calculator. The harder mathematics contests later on will also not enable you to use a calculator anyways. So that's why we can't use one. You mark A, B, C, D, E. Obviously, those are the 5 answer choices. If you don't answer a question, you get 1.5 points for it. If you do answer a question and you get it wrong, you get 0. If you do answer a question but you get it correct, you get 6 points. So that's what we want. We want 16 times 6. So if 16 correct will get me the goal. 15 correct and 4 no answer will get me the goal. 14 correct and 8 no answer will get me the goal, and 13 correct and 12 no answers will get me the goal. So all of these combinations are possible. Of course, if I score better, then that's better, but all these combinations are possible. It will make me pass to the next stage, the AMC competition, which is American Invitational Mathematics Exam. So obviously there are also other things like the mean and the median and the DHR, Distinguished Honor Roll, and the Honor Roll. The Honor Roll is the same as the AMC floor in this case. The floor just basically means the qualification score. So usually they're not, but most of the time they're about this. They're similar, right? Because the top, I think it's the top 5% that get to participate in the AMC, and then the top or maybe the top like 10% get the honor roll, or the top 5 I don't actually remember. I know DHR, Distinguished Honor Roll, is the top 1%. But Honor Roll and Amy Floor, I think, is the top 5%. One of them is the top 5, one of them is the top 10. That's actually quite crazy to think about it. The 5% and the 10% will be the exact same. But I don't know what the criteria for the Honor Roll is. I do know the criteria for Distinguished Honor Roll. So, okay. We will start in an hour. We will start now, actually. I think you see the timer right there, 1 minute, hour 15. We will start in 3, 2, 1, go. Let's go. Question 1. Pablo buy popsicles for his friends. One single popsicles, $1. 3 pops. Okay, so he has $8. So these and these. So it's 2 times 5 plus 3, 13. D. Next, the sum of two non-zero numbers, real numbers, is 4 times their products. What is the sum of the reciprocal? A sum of two non-zeros, real number, is 4 times their product. Okay, so A plus B, 4 times A plus B is equal to, wait, no. The sum of two, okay. A plus B is equal to 4AB. That looks like 1/2 and 1/2. 1/2 plus 1/2 is 1. 4 times 1/2 times 1/2 is 1. So I think it's 1/2 plus 1/2. So if it's 1/2 plus 1/2, then the reciprocal of the two numbers is 4. Yeah. Miss Carroll promised that anyone who got all the multiple choice questions right on the upcoming exam would receive an A on the exam. Which of the following statements necessarily follows logically? If Lewis did not receive an A, then he got all of the if Lewis did not receive an A and he got at least one of the multiple, maybe, probably not though. If Lewis got at least one of the multiple choice question wrong, that's the same as B, so probably not. If Lewis received an A, then he got all, no. None of them are right. He promised that anyone who got all of the multiple choice questions right on the upcoming exam would get an A on the exam. So if they received an A, then if they did not receive an A, no, not A. If Lewis did not receive an A, then he got at least one of the multiple choice questions wrong. If Lewis got at least one of the multiple choice questions wrong, then he did not receive an A. If Lewis received an A, then he got all of the multiple choice questions right. I mean, that's possible, but he could have also received an A through other means. I don't want to answer this. If Lewis did not receive an A and he got all the multiple choice questions wrong, that's not right. If Lewis did not receive an A, then he got at least one of the multiple choice questions wrong. If Lewis received an A, then he got at least one of the multiple choice questions. If Lewis received an A, then he got at least one of the multiple choice questions right. I mean, this just makes sense semantically. If Lewis received an A, then he got all of the multiple choice questions right. And when my brain works better, I'm gonna go back to that question. Jerry and Sylvia wanted to go from the southwest corner of a square field to okay, headed northeast. Okay. So it's root 2 over 1. Or 1 over root 2. Root 2 over 2. Root 2 over 2. So root 2 over 2 is about 0.7. So it's about 30%. About 30% shorter. 1.4 compared to 1. At a gathering of 30 people, there are 20 people who all know each other and 10 people who know no one. People who know each other hug, and people who don't know each other shake hands. How many handshakes occur? Okay. 10 people who know no one. Okay, so there's there's obviously the 10 people who know no one. The amount of handshakes will be 9 plus 8 plus 7 plus 6 plus 5. So it will be 9 plus 8 plus 7 plus 6 plus 5. That's 45. Plus 4 plus 3 plus 2 plus 1. 45. Right? And then everyone will also, the 10 people will also take handshakes with the 20 people. So that's 10 times 20 is 245. I really hope double counts don't count. I really hope it's not 490. Okay, whatever. Joy has 30 thin rods. One each of every integer length from 1 centimeter to 30 centimeters. He places the rod with lengths 3, 7, and 15 on the table. She wants to choose a 4th rod so that she could put these 3 to form a quadrilateral with positive area. How many of the remaining rods can she choose as the 4th rod? Okay. So there's this rule. If you have one with 15 and then one with 7 and then one with 3, like that, you need, let's say, okay, so if you have 15 like that and then 7 and 3, like kind of like that, this 7, that's 3, and that's 15, you need at least a 5. So 5 will work. 5 won't work, 5 won't work. So 1, 2, 3, 4, and 5 don't work. They just can't work. But 3 and 7 and 15, 3 plus 7 plus 15 is 25. So 25, 26, 27, 28, 29, and 30 also don't work. Do the rest work? Well, let's find out. So 6 works. 7 works. Because if you add any 3, so if you add any 3, it has to be bigger than 1, right? So from 6 to 15, every single time you add these 3, it's bigger than the biggest one. So that's why the quadrilateral can have positive area. However, when it gets to 16, then the other 3 will add to that biggest length now. So yes, everything else does work, and the only things that don't work is 1 through 5 and 25 through 30, which means D is the correct answer. Next. Define a function of positive integers recursively by f of 1 is 2, f of n is f of n minus 1 plus 1 if n is even, then f of n is f of n minus 2 plus 2, and if n is odd, n greater than 1. What's f of 2017? Well, let's find a pattern. F of 1 is 2. F of 2 is f of 1 plus 1. So f of 2 is f of 1 plus 1, so f of 2 is 3. Okay. And then f of 3 is f of 1 plus 2. F of 3 is f of 1 plus 2, which means f of 3 is 4. F of 4 is f of 3 plus 1, which is 4 plus 1, which is 5. F of 5 is f of 3 plus 2, which is 4 plus 2, which is 6. So it looks like it's counting by 1. F of 6 is f of 5 plus 1, which is 7. So yeah, it's literally just counting by 1. 2018 B. F of 2017 is 2018. Let S the the region consisting of all points in 3D space within all points in 3D space within 3 units of line segment AB has volume 216 pi. What is the length AB? Okay, so if you think about it, it's gonna be a cylinder and 2 spheres. So if it's like this, and then it will be something like something like that. Right, that's the region with all 3, and then you also get a sphere. Something like that. So the area or the volume formulas are so this will be 3. Oh, sorry. This side right here would be 3. So it'll just be a 1 with 3 radius. So it's 4/3 pi r cubed. 3. So 3 cubed is 27. Divided by 3 is 9. 36 pi. 36 pi is the sphere. Now for the cylinder, it's it's pi r squared L. So it's pi 3 squared times h or L. I'm just gonna use L. Plus 36 pi equal 108. So I think L is 8. Or well, no, not 8. 72 to, no, it is 8. Oh wait, no, it's 216. I'm sorry, 216. 180 divided by 9 pi. This should be 20. Should be 20. D. Let S be the points x, y in the coordinate plane. Okay, let S be a point x, y such as 2 of 3 of the quantities 3, x plus 2, and y minus 4 are equal, and the third of 3 quantities is no greater than a common value. What does that even mean? Oh, okay. It's less than. It's less than the common value. Okay. Okay. 3. I think it's line. Or maybe it's 2 intersecting lines. So if we keep x plus 2 constant, right? So x plus 2 equal 3. Let's make x plus 2 equal to 3. So x will be 1. And then y can go ham. Y can be anything. Y can be like I think it will be like a horizontal line or some shit. So if x equals 1, it will be 3, and then y can be 6 or 7. Basically, y will be less than 7. If y is 7, then x is less than 1. So let's draw that graph right now. So if x equals 1, y is less than 7. So something like this, right? Assuming that's 7. If y equals 7, then x is less than 1. So something like this. So that's two rays. Now x plus 2 and y minus 4 has to be equal to 3. Or x plus 2 has to be equal to y minus 4. I'm sorry. X plus 2 has to be equal to y minus 4. So that means that's the equation y where y equals x plus 6. So y would be equal to x plus 6, and that and they both would have to be less than 3. So or 3 would have to be less than both of them. or I'm sorry, this would be greater than or equal, less than or equal to. So if x, okay, let me, x plus 2, y minus 4, x plus 2, okay, so x plus 1 is less, 1 is less than x plus 2, 1 is less than y minus 4, so x is less than negative 1, y is less than 5. Wait, no. X is greater than negative 1. Y is greater than 5. 5 is less than y. Negative 1 is less than x. And this. So you'll have y equals x plus 6. Something like that. Okay, but y has to be greater than 5. So like right here. And x has to be okay, y has to be greater than 5, and x has to be greater than negative 1. So it'll probably be something like right here. It'll cut off right there. So it'll be 3 rays, definitely, with a common point, E. I think so. I think so. I don't want to spend too much time on that question. That was a time waster. Chloe chooses a real number uniformly from 0 to 2017. Lauren chooses a real number uniformly from 0 to 4034. What is the probability Lauren's number is greater than Chloe's number? I think it's 3/4. I just have a hunch it's 3/4, but I think it's better to do casework. It's at least 1/2. At least 1/2. So it's not 1/2. Because 2018 to 4034, that's now for the situations where it's 0 to 2017 to 0 to 2017, it's exactly 1/2. So it's 3/4. See. Claire adds the degree measure of the interior angles of a convex polygon and arrives at a sum of 2017. She then discovers that she forgot to include one angle. So whatever it is, it has to be a multiple of 180. So 37 will get you 2054, not a multiple of 180. 63 will get you 2080, which is not a multiple of 180. 117, not a multiple of 180. 163 will get you 218. No, okay, so it's D. Yeah, so there are 10 horses named horse 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They get all their names from how many minutes it takes for them to run one lap around a circular racetrack. K, okay, times 0, okay, the horse starts running in the same direction. They keep running around the circular track at their constant speed. The least, okay, let's see the least time, at least 5 of the horses. What's the sum of digits of T? This should be easy. So 2520 is the greatest common or the lowest common multiple of 1 through 10. So, I mean, the lowest common multiple of okay, that won't work. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Oh, I'm sorry. Oh gosh, no. And just put 10 up here. I think 1 will definitely be in. 2 has to be in. 1 is like the best number in the world. And 4 will be in because 2 is in. Because 4 will cover for 2. Now I'm thinking of 8 and then 3. Because 8 will cover for 4 as well. So that will be 24 minutes, which the sum is 6. Now I don't know if that's right or not, because I don't want to introduce a new prime in there. Oh, wait, no, that's wrong. That's definitely wrong. 3 times 2 can be 6. We can use 6, and that will be even closer. So then the greatest common factor in this case will be 12, which is 3. I'm pretty confident that's the right answer. So B. Driving at a constant speed, Sharon usually takes 180 minutes to drive from her house to her mother's house. Okay. Okay. So Sharon usually takes 180 minutes to drive from her house to her mother's house, but after driving 1/3 of the way, she hits a bad snowstorm. So her 120 minutes turned into 216 minutes. Right, because 60 minutes is just the normal speed. So that's a 4/5 increase. That's a 4/5. Okay, 20 miles per hour. So I think it went from 45 to 25. I think it went from 45 to 25, because this it takes 1.8 to get here, so it decreases by 1.8 accordingly, I think. So this, let's see if it's right. So 120 minutes at 45 miles per hour would be 90 miles. And then at 216 minutes at 25 miles per hour would be 36, so that's also 90 miles, yes. Yeah, so 90 miles and 90 miles. So usually it'd take her 20 minutes to drive 45 miles per hour. So if she drives 45 miles per hour for 3 hours, that's B. Alice refuses to sit next to Bob or Carla. Derek refuses to sit next to Eric. How many ways are there for 5 of them to sit in a row of 5 chairs under these conditions? So we have A, B, C, D, E. So obviously it's not 120. Which is the amount total. So they can't be next to each other. Okay, they can't be next to each other, so they have to be at least okay, so let's do the D. Let's do the D and the E first, because that's simpler. So if E is right here, D can be here, here, or here. Right? If E is right here, D can be here, here, or here. And any other letter can be here, I think. So if D is here, there's 6 options. If D is here, there's 6 options. If D is here, there's 6 options. So 18. I'm just calculating all of the combinations for right now, and then I'll take into account the ABC dilemma later. So if E is right here, then D can only be in 2 spots. So that will be 12 combinations. If E is right smack in the middle, D can be in 2 spots. So if E is in the middle, then D can be in 2 spots on either side, and that will be 12 combinations. If E is right here, 12 combinations, and 18 combinations if E is on the edge. So that's probably not the best way to work it out, because that'll get you 72. That doesn't help me at all. There is a symmetry on this though, so that's pretty nice. So if D is right here, and then E is right here, what are the possible ways that so if Alice refuses to sit next to Bob or Carla, then Alice has to be here. So then B and C has to be here. So that's two options. 2 options if D is right here. If D is right here, instead, then B and C has to be located in this section, basically. So that's two more options, because B and C can be interchanged. If D is right here, though, at the end, then A is forced to sit next to B or C. So there's no options in that case. So that's gone. Now, if E is right here, then D can be right here or right here. So if D is right here, then there's the full 6 options, because A will never be next to B or C. But if D is right here, there's only 2 options, because B, C right here, and then A is right here. If E is in the middle, then D has to be right here or right here. And this pattern means 2 options, so it's 2 plus 2. If E is right here, then we get the same as this, 6 plus 2. And then if he's right here, we get the same as this, 2 plus 2. So it's 2 plus 2, plus 2 plus 2 plus 2 plus 28. See. 2 plus 2 plus 6, plus 2 plus 2 plus 6, plus 4 times 2, which is 28. 28, okay. Yeah, nice. Let fx equals sine x plus 2 cosine x plus 3 tan x using radian measure for x. In what interval does the smallest positive value of x for which f of x equals 0 lie? I'm just gonna use calculus. I'm just gonna use calculus. Should I just? I think I should just use calculus. F of x equals 0. Okay. So f prime of x equals cosine x minus 2 sine x plus 3 over cosine squared x. Does that help at all? I don't think that helps. I don't think I can try. But I don't think that actually helps. I think we're just gonna have to do some graph analysis with the 3 functions. So sine goes like this. Cosine goes like this. Let me draw a better graph. And then tan goes like this. Tan's just disgusting. And tan has asymptote at pi over 2, I think. Yeah, so tan goes like this. So does that help at all in me determining where the first f of x equals 0 is? Okay, so in the first quadrant, it's a lost cause. In the first pi over 2, it's not going to happen. Cosine dips below, and tan also dips below. So okay, so that's gone. No way. And because this is gone, no, I can't eliminate any other choices. So that's gone. So sine has its maximum value right here. So that's 1. Right? Cosine will be at its minimum value, and tan will be undefined. So that will be negative infinity. That wouldn't work. Tan x equals cosine x. Let's check this interval first. I feel like this interval is easier to check right here. This pi to pi to 3 pi over 2. So sine x would be like, right, this will be sine, and then if sine and cosine's the same, this is just 3 sine over cosine. So maybe I can 3 sine x over cosine x equals 0. Uh, 3 sine over cosine equals sine plus 2 cosine minus 3 sine equals sine cosine plus 2 cosine squared. Yeah, this is the part in the stream where I struggle. That's minus 3 sine. This is equal to 1/2 sine 2x. That's an identity. And this is equal to 2 times 1 minus sine squared x. So the first part, when they're all 0, is when x equals 0. Well, no, that doesn't work. It doesn't work like that. Maybe that's easier to differentiate. But we can't just differentiate like that. Okay. I'll skip this question. I'm spending too long on this question. I have a hunch it's either B or C or D. I don't think it's E. But I'm spending too long on this question. Okay, 17 looks easy. There are 24 different complex numbers z such that z to the 24 is 1. For how many of these is z to the 6 a real number? So this is just an application of De Moivre's theorem. So that's just every 24 degrees you'll get 15 degrees for every turn in the complex plane. So it'll be 15, 15, 15, 15. We just gotta solve for that when it's -1 and when it's 1 in 6 turns instead. So 30 degrees will be one of them. If you turn them, it will be 180. 60 degrees, if you turn it, will be 360. 45 degrees, if you turn it, will be 180. Wait, no. Yeah, so 30 degrees, not 15 degrees, I'm sorry. So 30 degrees, 60 degrees, 90, 120, 150, 180. So it's D. In the figure below, semicircles with centers A and B with radii 2 and 1 are drawn in the interior with diameter, just kidding. The two smaller semicircles are externally tangent to each other and internally tangent to the largest semicircle. What is the radius of the circle centered at P? Okay, so that's P, right? That's P, so what's the radius? Okay. I suck at my geometry questions. I'm not good at geometry questions at all. But I'm gonna try to fiddle with this some more. How many minutes do we have left? We have 40 minutes. We still have a lot of time. I'm gonna fiddle with this to try to get some sense out of it. That's 3, definitely. This is definitely 3. 3. That's 2. Or, well, no, not, that's 6. I mean, 6. That's 2. 2. 2, 2, 1, 1. So that's 3 as well. Also 3. Right here. Also 3. So that's also 3. Let me draw a right here. That's 3. 3. Okay, how's that gonna help? All of the choices that I have is less than 1. Or greater than 1. So that's good to know, I guess. It's greater than 1. I know that tangents are always perpendicular. If you draw a triangle that's tangent, it's always perpendicular. But how is that going to help? I don't know. I genuinely don't know. So yeah, this would be perpendicular. So maybe I could do some triangle theorem shit with it. Pythagoras. But I definitely wouldn't know what that angle is. I don't think it has anything to do with area. I also happen to know that this is a right angle. So is that going to help me at all? Let's see. 6. Okay. Let me just remove this. Remove. I kind of want to work this on paper. I want to show you guys how I work through these questions as well. So that would just be 3, but I'm not sure if that's a right angle. That's the thing. I don't think it is. I don't think this is a right angle. If this is a right angle, it's life-changing. Like, actually fucking life-changing. But, I don't think it is. So this... I don't know if that's a right angle or not. But this is x plus 1, and that's x plus 2. And that's 3. So if we can prove this is a right angle, then that's automatically, right, we'll be able to solve it. So is it a right angle? Let's see. If we cut oh, I'm sorry. Like one of these, if we prove this is a rectangle, then I don't see any reason why that's not a right angle. I can prove that these two are right angles right here by the tangent theorem that I was talking about. Let me go to the other questions. Let me go back to this later. S of n equal to the sum of the digits. Okay. Let S of n equal sum of the digits of, okay, so S of 1507 is 13 for particular positive integer. S of n is 1274. Which of the following could be the value of f of S of n plus 1? So this is some mod 10 shit, I think. Yeah, this is a lot of mod 10. This is some mod 10 shit. So let's see a number with all nines. Let's use a number with all nines as an example. I know it's not the best example, but I gotta have an example. So if there's 100 nines, it'll be 374. If there's 40 more nines, it'll be 14. And then if there's one more 9, it'll be, so 141 nines. So 141 nines with a 5. So a 1 is possible. So if you add 1 to it, the next number is definitely possible. So that doesn't really help. That doesn't really help at all. So 1274. Okay, so if you have like a big number, let's say 2, 3, 4, 5, 6, 9, right? And then you add 1 to it. The sum of this number is 29. So if you add 1 to it, you get 2, 3, 4, 5, 7. 2, 3, 4, 5, 7. Which means it's 2 plus 3 plus 4 plus 5 plus 7 is 21, right? 21. So it'll be 8. It'll be down by 8. Now let's say if you have 2, 3, 4, 5, 9, 9, which the sum is 32, and if you add 1, you have 2 plus 3 plus 4 plus 6, which is 15. 15, 17, right? Is it 17? Yeah, so it's 17 off. So if you have 2 plus 3 plus 4 plus 9 plus 9 plus 9, that will be 36. And if you add 1, it will be 10. So that's 26 off. So what I'm hinting at is basically, if you add 1 to this number, the sum can decrease by 8 and then a mod 9. So let's check if any of these is true. 1265 is wrong because if it's decreasing by 8, it can't possibly be 1265. If you subtract 8 from 1274, you will get 1266. 1266. Now we can check for mod 9. So 1266 subtract 1239 is like, I should be able to know this automatically, but it's kind of sad. 27. So it should be it. This should be it. But let's check the other ones. 1254. Is 1254 divisible by 9? No. 1254 is not divisible by 9. And then 3 would fall under the same argument. 1 is 1266 subtract 1 is 1265, and that's not divisible by 9 either. So D is the right answer. Okay, I'm actually pretty proud of being able to solve that question pretty quickly, so that's really nice. A square with side length x is inscribed in a right triangle with side lengths of 3, 4, and 5. Yeah, they really like the 3, 4, and 5 triangle. 3, 4, and 5. So it's one of vertex, yeah, okay. Square with side length y. Side length, okay. Inscribed, so it has to be like this, right? I think so. So we can use coordinate geometry to find this out. Okay, let's use coordinate geometry. So that would usually be, that's, the slope is -4, the slope is -3 over 4, so the slope up will have to be 4 over 3, but it's not. So the slope is -3 over 4, I'm guessing this slope is just 1/2 x, because, or y over x, so it's just 1x, I mean. So it will be y equals x is equal to, y equals -3, and it will be 3 over 4x minus 3, or -3 over 4x plus 3, I'm sorry. Is the stream going? Okay, it reconnected, okay. Nice. 7 over 4x equal to 3, x equal 12 over 7. 12 over 7 is the size of the first triangle. Now we have another right triangle, side length y this time. Let me fucking draw a nice triangle for you guys. This is ridiculous. 3, 4, and 5. But this time, something like this. So this is a little bit harder to visualize. Mainly because I don't know what the equations will be. I think it's a system. I think it's a system instead now. Just try not to be too flustered. So if this is the y-axis and this is the x-axis, then our equations will have so however far our equations are away from each other, the diagonal will have to compensate for that, or like the perpendicular sides of the other sides of the square, and they can't be too far. So let's try some numbers. See if I can find a pattern. Let's try some numbers. How long do I have left? I have about half an hour. So if this is like 3/5 or -3 over 4 is the slope, so 3 over 4x, and then this is just plus 3. So that's our first line. Our second line is a minus 3 over 4x. Our third line is a plus, like this line right here is a plus 4 over 3x. And then this line right here is I think I can calculate it. If we stretch this down to if we stretch this down to over here, then that will be, well, how long is this line? How long is this? This will be s. So if we would try to, if we want to find s, yeah, that doesn't work. Yeah, I don't think this method. So okay, let's just put 12 over 7 for now, because I don't know what the heck I'm doing, clearly. Let's try some numbers. We'll try some numbers. 1.5. Let's try 1.5. Side equals 1.5. So if this side's equal to 1.5, then so for every okay, that probably wouldn't go very well. So that's 4 and that's 3, right? That's 4 and that's 3. So if it's 1.5, if the side's 1.5 long, then this will be 1.2, and this will be 0.9. So this will be 1.2, that will be 0.9, that will be 1.2, 0.9, 1.2, 0.9. Does that agree with our equations? So it's y equals negative 4 over 3x. Or negative 3 over 4x plus 3. And then if we have a 1.2, 0.9 like this, then our points, our coordinate points, for, well, this is, if this is 0.9, this will be 1.2. So that's 0.9, 1.2. So the coordinate point right here is simply just, I think, 0.9 comma 1.2. No, it's not 0.9 comma 1.2. You have to overcome this bench as well, this little bit as well. So it'll be something like 0.9 plus 1 is 2.1 comma 0.9. Does that make any sense? Does that make any sense? No, it doesn't make any sense because I reversed the 2.1 comma 0.9. And 1.2 comma 2.1, 2.1 comma 0.9, 1.2 comma 2.1. Does 2.1 comma 0.9 follow this equation? If I put 2.1 in here, that's what's that? That's 10 over 7? No, 10 over 3. So 10 over, no, not 10 over 3. I'm sorry, 21 over 10. This equation makes no sense anymore. Negative 3 over 4x plus 3. Okay. If I inscribe a tangle like this, yes, because the equation makes no sense, I think it's not the right answer then. X, y, y, x, x, y, okay. X, y, x, y, x, y, x. Okay, I'm just going to use A and B to not confuse it with the other one. So A will be the longer one, B will be the shorter one. A, B, A, B, A, B. So y is equal to this. Y minus y1, or, well, we already know what this is, but in this case, instead, we'd have a point of 0 comma b, right? 0 comma b. So that means y minus b equals the same slope, x. So it's y is equal to negative 3/4 x plus b. Okay. And the condition is, what's the condition? A squared plus B squared equal to S squared. This is the distance. The distance is A squared plus B squared. How are we going to make sure that the distance between these two are the same as the distance between these two? Or the distance between these two is the same as the distance between these two? Yeah, I'm just not going to think about the geometry questions anymore. They're making me want to implode on myself. I don't want to do them anymore. How many ordered pairs A and B such that A is a positive real numbers and B is an integer between 2 and 200 inclusive, satisfying the equation log base BA 2017 equals log base BA of 2017? Can I make this simpler? Or so this will be something like natural log of A over natural log of B to the 2017 power. No, that doesn't make it simpler at all. That doesn't make it simpler at all. No, never mind. Okay, how many ordered pairs A and B? So the A is positive. Okay, B is between 2 to 200. Why does it have to be between 2 to 200? Let's try B equals 2 and A equals 2. If B equals 2 and A equals 2, and that'll get you 2017, and that'll get you 1. So that doesn't work. What if it's just double? If A is 4 and B is 2. If A is 4 and B is 2, then log base 2 of 4 is 2 to the 2017. And then this is 2 to the, 2 to the 2017 equal to 2017 times 2. Yeah, that doesn't work either. How many ordered pairs A, B such that A is positive real, B is integer between 2 and 200 inclusive? So for what value of A does B equals 2 work? You'd have log base 2 of A to the 2017 is equal to 2017 log base 2 of A. Yeah, I trust that there's a number that this works with. There probably is. There has to be a number that this worked with. It's between 1 and 2, because this is 1, and it shoots straight to 2 to the 2017. This is calmer or it's between 2 and 4. I'm sorry. So if A is 2 in this case, then A would just be 2017. And then if A is 4, then it will be 4034. There's a number in time by the fucking intermediate value theorem that this thing is the same thing. So it's not 198. It's at least 199, I think. Same thing for 200, right? So 200, if it's log base 200, and then 2017 log base 200, if we put 200 in here, it'll be 1 to the 2017. If we put 200 in here, it'll be 2017. So that'll just be 1. But if we put 40,000, then it will be 2017. It'll skyrocket. It'll be a massive number. So yeah, it'll work for at least 199 numbers. Now let's see about the negatives. So we'll work for the negatives. Let's see. So 2017 is a odd number, which is good because that means negatives can exist. So let's do the log base 2 example again. Log base 2 of 1/2 now to the 2017. This will get you negative 1 to the 2017 power, I think. Am I dumb? I hope I'm not. Yeah, negative 1 to the 2017 power, and that's equal to log base 2 of 1/2 to the 1/2 to the 2017. So 2017 times negative 1. So this means negative 1 equals negative 2017, which doesn't make sense, right? But that's not what we're trying to find. We're trying to find so that when it becomes negative 2 to the 2017, it skyrockets to an amazing number, a ridiculous number. But when we take log base 2 of negative 2 to the 2017, or I'm sorry, if we take log base 2 to the 1/4, if a equals 1/4, then we'll only get 2017 times negative 2. So I think that also works. So it's C as well. So that's what I'm going to go for. I'm going to go for C. Okay, we have 15 minutes left, so I'm gonna go to the rest of the questions and see if I can choose one question that okay, G is easy. This is easy. So for certain real numbers, this has 3 distinct roots, and each root is also okay. So basically, they're saying that g of x times x minus like d equal to f of x. F of x equals g of x times x minus d, and g of x is this. So put this in parentheses, x minus d. So it'll just be what, x cubed times x is x to the 4th. Yeah, ax squared times x minus d times x cubed. So that's both x cubed. So it's a minus d is equal to 1 because that's f of x. For the x squared terms, we have a times negative d, and then 1. So 1 minus ad is b. For the x terms, we have, where is it? 10 minus d, I think. Yeah, 10 minus d is 100. And then for the final terms, minus 10d equals c. Minus 10d equals c. So let's find it out. D is equal to, in this case, minus 90. So C is 900. Not important. I don't think that's that important. Let's check out what A is. A is A is 91, I think. So negative 90 is 90. A is negative 89. A is minus 89. So then B is minus 89 times minus 90. Minus 89 times minus 90 is what? 7,000. No, 8,010. 8,010. So B is 8,011. So what's f of 1? Plug in the numbers. Sorry, this is positive 900. Plug in the numbers. 1 minus D is 1 minus 90, so that's 91. And then 1 plus 1 times negative 89, that's minus 88. Plus 1 minus 87 plus 10 minus 77. So what's minus 77 times 91? That's 637, 7007. 7007. C. Another geometry question. I'm not doing geometry questions. Not anymore. Not today. The vertices of a centrally symmetric hexagon is another geometry question. I'm not doing that. That might actually be doable, though. Because I'm okay at long numbers. So a set S is constructed as follows. To begin, S is 0 to 10 repeatedly as long as possible if X is an integer root of some polynomial. Okay. X is an integer root of some polynomial. An xn plus an minus 1 xn minus 1. Okay. Okay. I just, what does that mean? I actually don't know what this means. S is 0 and 10 only. Okay. So S only contains 0 and 10. And it has to be an integer root. Okay. So what we can do is X. Well, let's make a pattern right here. So let's try 10 x squared plus 10x equals 0. Then we'll have x equals 0 and x equal to, in this case it's 10x times x plus 1, so negative 1. So negative 1 will be part of our solution in that case as well. So then now we can do x squared minus 1 equals 0, and this will get us positive 1. So now all of our, now our set has expanded to at least 1, or 0, 1, negative 1, and 10. Okay. There's definitely more. There has to be more. Can we do group factoring and find something else? X squared plus 10x plus 1. X cubed minus x squared plus 10x minus 10. Or, well, no, we can't do that. X cubed plus x squared. Or minus x cubed plus x squared. I don't know, minus x squared plus 10x plus 10 equals 0. That will get you 10 times x plus 1. And then this is minus x squared times x plus 1. That's not a viable solution. No. No, we can't do that. 10x minus 1 equals 0, x equals 1/10. That's not an integer. 10x minus 1 I'm tempted just to guess 4, but I don't want to lose 1.5 points. A square, okay, let's do this for a little bit. A square drawn has, okay, so the coordinate's kind of like that. The particle starts at 0, 0, every, okay, one of the 8 lattice points. So it'll be something like this. Those are the lattice points, right? Okay, okay. Particle will eventually hit the square for the first time, either at one of the 4 corners of the square or one of the 12 lattice points in the interior. Probability will hit a corner rather than an interior point is m over n. I like that. That's a nice question. The only problem is I don't think I have enough time to solve it. I have 4 minutes. Maybe I'll try. So it's something like this. Okay, so this is a lot harder because it doesn't just list the probability. You actually have to work it out. So I think I'll just simplify it to a simpler case and multiply by 4, like that. So what's the probability that we hit this? There's a 1/8 chance, right? Oh god, there's a 1/8 chance. That's the thing. So we can't just like multiply it up to the, or blow it up. That wouldn't work. Let's say we just deal with this then. So if it goes exactly here, that's a 1/8 chance. 1/8 chance. Oh no, I'm not good with symmetry. I'm just gonna check the rest of my fucking answers now. Let's check the answers. 2 popsicle, 5. Okay, yeah. I didn't answer this question. I'm just gonna go for it. D. Oh, wait. Okay, my brain's working better now. It's definitely B. It's 100% B. It's B. Okay, let's keep going. Larry walks east, due north, route 2. Okay, at a gathering of 20 people. No, the 45 handshakes to 245. Okay. Joey has 3 to 30 tin rods and 1 of inch lane, 1 centimeters, place a rod with 3. Oh, if he did place the rods with 3, 7, and 15 already, they wouldn't count, right? Yeah, so I might have to recount. Shit. How much time do I have left? I have fucking 1 minute. I have 1 minute to recount. How many of the remaining rods can she use? So it will just be 27 now. So 1, 2, 4, 5 is off the window. 25 through 30 is off the window. And obviously 7 and 15 is off the window, so whatever number I had was divided, just subtract 2 from it, will be 17, I think. So it will be B instead. This is such a messy, that's one of the messiest. Okay, but let's continue. How many minutes do I have left? I have 42 seconds. 216 pi 20, okay, 2018, because it's just a step function. 3 raised with common point because I measured it, because I had it to be like that. 3, so it's 1, 2, 3, 4, 6. 143 because it has to be divisible by 180. 3/4. B, C. Do I just want to guess for this one? Do I just want to guess for this one? I don't think it's... I think it's C. I think it's C. Wait, no. Wait, that's negative. Okay, well, that's it. Time's up. Let's check our answers. Let's check our answers, ladies and gentlemen. I have the answers. I'm going to look up the answers. AMC 2018. I think I crossed it out just in time for me to not have my answer count, so I get the 1.5 points. I don't know. I'll watch the stream again to see if I actually did cross it out just in time. But AMC 2018, 12A 2018 answers. It's 12 fucking 15 already. Holy shit. Let's check the answers. So these are the answers right here. I'm gonna open the thing up a little bit bigger. Right here. These are the answers. All the answers that I didn't put on the left won't count. So let's see how I did. Let's just move this to right here so we can see the problems. Okay, DCB, DCE. E is the right answer, apparently. If Lewis received an A, then he got at least one. If Lewis received, is this is 2018. I'm sorry. I'm supposed to use 2017. Right here. Okay, answer key. Okay, there you go. That looks a little bit better. DCB, nice. DCB, ABB, nice. BDE, nice. CDB, nice. BC, and I crossed it out. It is D. Okay, so D would be the right answer. So in this area, I guess it would be all negative or something. But D would be the right answer in this case. Not A. So I'm just gonna kind of put a box around this because I don't know if I crossed it in time or not. But let's say I did. So let's just say it's 1.5 here. We don't know though. 16 is B, so I'll work that out later to see why the heck it's B. But 17 is D, so that's right. 18 is D. 20 is E. 20 is E. I guess there's another solution I wasn't able to find, so I'm gonna cross that out. 9. I don't know what 19 is. I didn't check it. 21 is, I should probably get rid of this. Did I answer any of the last 5 questions? Did I answer 3? I answered 23. Okay, so 23 is C. Nice, I got that right. And 20, okay. So how many answers did I get right? I got 1. It's 21A. 21 is not A. 21 is 9. 9 elements. 9 elements. How does that work? How does 9 elements work? Oh. That's how 9 elements work. That's how 9 elements work. So that's at least 5 elements already. So what else can you do? What else can you do to get the other 4 elements that we're trying to look for? So this will be 0, 4, 1, negative 1, negative 10, 10, negative 10. x squared plus 10x plus 1. I know x squared plus 10x plus 11 has a solution, but I don't think that works. X squared plus x plus 10. Does that work? Or x squared plus x minus 10? X squared plus x minus 10? X minus... No, that wouldn't work. That definitely won't work. Because 10 doesn't have any... Yeah, so these are the only ones I can find. For now. I'll try to go over some of these questions later again, but I got 1 right. I got 2 right. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I am safe. I'm safe, ladies and gentlemen. 17 times 6 is way more than 96. Or, well, it's one question more than 96. But there are some questions I also didn't answer, like 15, 16, 19, 21, 22, 24, and 25, which will get me 7 times 1.5 more points. So 7 times 1.5, that is 113.5 points. And that is my total score for the AMC 2017 right there. So I'm not going to be doing the punishment. Next week, I'm going to be doing the American Invitational Math Competition, the AMI, with my 113.5 score, and I will see if I can qualify for the next competition in line, the Mathematical Olympiad of the United States. And if I don't make that, then maybe you guys can send me a punishment for me to do. But for now, I did not get the punishment because I was able to successfully solve the problem. I'm sorry, there's still the overlay that I don't want. I'll just like get that out of the way. Yeah, so here's the score right here. So I did not fail this time, but I might do it next time. So I will leave the stream up, and I will do the American Invitational next week, or maybe not next week, but maybe a week after, because it's 3 hours long. It's a ridiculously long invitational. There's no multiple choice. It's really hard, and it's really probably boring to watch. It's even more boring than today. Today probably looked really boring to watch. Next time it will be worse. So stay tuned for that. But what's not boring is me failing the AMI and having to do a punishment. So that's probably going to happen. But anyways, that's going to be it for today. If you guys have any more, I don't know, challenges for me to do, maybe on this channel, maybe on the main channel, please suggest it in the live stream comments. I don't know if anyone put any comments on the live stream, in fact. I don't see it. Okay. Yeah, I don't see anyone. I don't see any comments on the live stream. So, yeah. If you guys want anything, please tell me to do that on my Consider Your Idea, because this channel is mainly for education, but my main channel is for a bunch of random stuff. So maybe a bunch of random stuff will appeal to you more than education, math, and science. So until then, I'll see you next time for the